Hi class, welcome again to another session on biomaterials. So we have finally managed to reach the last topic of our third unit, which is electrospinning. So electrospinning is a straightforward, cost-effective technique for manufacturing polymer nanofibers. So in this method, electrostatic force is used, and this force produces polymer fibers that range from a few microns to tens of nanometers in diameter. So this method used to be called electrostatic spray or electrostatic spinning earlier, and now it's just called as electrospinning. So in this method is an effective way to improve tissue scaffolds or to manufacture tissue scaffolds with most of the precise features required for tissue engineering, and has recently been used successfully for manufacturing polymer nanofibers for tissue engineering applications. So basically, tissue scaffolding and tissue engineering applications find widespread applications for are, are widely benefited by electrospinning process. So such polymers, or the polymers that are manufactured using this method, exhibit better cell growth because it facilitates cell addition and then cell expression and then transport of oxygen and nutrients in the cell. So basically it promotes cell growth. So you have an experimental setup for electrospinning where you have a machine that consists of majorly three parts: the spinner, a fiber collector, and the high voltage power supply. So the polymer is fed into the system through the spinneret, and with the help and that this is done through a syringe pump at a steady and controllable speed. You just use like an infusion pump which steadily pumps the polymer solution into the system or into the spinneret. Now, the rate at which the polymer is fed can be controlled by controlling the concentration of the solution. So, the thicker the solution is, you know the rate of pumping would reduce, and if the solution is much thinner, then it can be pumped quite quickly. So the fiber is collected in a collecting device, and this device is placed below the spinner at an appropriate distance from it. So because if you place it too close to the spinner, then that might, the material before it falls into the collecting device might stick to it. Right? The polymer solution is converted into a charged polymer jet through the help of the high voltage low current power system. So the high voltage power supply is basically responsible for inducing charge because we are trying to use electrostatic force here. So we want the polymer to carry some charge and there's some static electricity in it. So the electrical power for the system is usually up to 30 kilovolts, and this is applied across the spinneret and grounded metallic counter electrode, which is a fiber collector, to facilitate the charge jet to eject from the spinneret tip towards the surface of the fiber collector. So now you basically apply charge across the spinneret and the collector, so which would attract the polymer fiber from the spinneret towards the collector. So it's just like how electrons get attracted towards positive energy. It's just like that. So electrospin fibers are collected on the surface of the collector. So this is a typical setup. So you have the syringe. Let's just get a laser pointer, right? Yes. So you have a syringe here, sorry, a syringe pump, and the solution, the polymer solution, is pumped through the syringe pump. The polymer solution is filled in the syringe. This pump is digital pump, so that would actually push the spindle, which would result in polymer traveling into the spinneret. So the spinneret tip, which also forms a Taylor's cone in the end, this is where you are applying potential. You are applying potential between the spinner tip and the collector. So there's a high voltage supply that is appearing. So this would charge the polymer, and the polymer gets attracted towards the collector, which is here. So there's an instability region here in the jet where the jet does not know exactly what happens. However, just gets collected in the collector or the counter electrode as it is called, and then you just scrape the material off the electrode. So the spinning mechanism to obtain the polymer nanofibers is rather complicated. Although this method looks fairly straightforward, the spinning mechanism is quite complicated because the electrode potential at the spinner results in an electrified pendant droplet at the tip of the spinner. So this pendant droplet actually results in the formation of the Taylor's cone. You know the tapered end at the spinner. So Taylor's cone is formed primarily due to two electrostatic forces, which is the electrostatic repulsion between the surface charges of the droplets and the Coulombic force exerted by the strong external electrical field. So these two forces actually result in the formation of the cone. It is not a physical cone, a physical part of the device. It's just the polymer material, forms that cone and finally comes down as fiber. So when the applied electrical field becomes greater than a critical value, the electrostatic force tends to exceed the viscoelastic force and the surface tension of the polymer droplet. So this results in the fine polymer jet ejecting from the Taylor's cone. So now this electric field has to exceed a critical value, and that critical value is based on the type of polymer that you use. So the polymer jet then moves towards the counter electrode, which is accompanied by rapid evaporation of the solvent molecules. Because you don't want the solvent in there, right? You just want the polymer. So different polymer strands in the jet are separated out due to the mutual repulsion, a phenomenon called as a sea spray. Right? So and this ultimately results in ultra-fine dry fibers because you are drying out the fiber as it falls and then you are separating it out. So these fibers can be collected as a grounded metallic target, typically in the range of a few nanometers. I think that's all I have to talk about electrospinning in this video. I hope you had a very fruitful session learning about the third unit. There's quite a lot of material available in your textbook. I highly suggest that you read that as well and formulate your answers accordingly, because if it is a long question, you should have sufficient material to write the answer about. So this is something that I want you to do on your own time, and I wish you all the very best. Thank you.